So we'll have some record of this. Okay. Before I start, remember, on Blackboard, you have in the tests and quizzes section, you have your midterm preview. It is counted as a quiz for this class, aside from the fact it's a preparation for the midterm. You should have this completed by Friday. If anybody has any questions on those type of questions, after you've tried it, I will give you an opportunity to ask me in class questions as to what you're not sure about. Don't forget that you have 2 chances to do that midterm preview. Then the mark that you get, the better mark is what goes down as your quiz mark. Also, starting on Friday, October 28th, right after this class, the midterm itself will be available on Blackboard. It will be in a section called midterm, and it will be available through the 31st. You have to make sure to complete it before the 31st. Again, allow yourself for each of these tests an hour's time, so that if you're going to sit down and you only have 20 minutes to do it, don't then pick a different time to start it, because once you start the test, you must complete it in one sitting. Also, make sure if you're not up to date on your Delta Math homeworks or quizzes, that you work on those as well. Those are good for review, and it also, you need it for your mark. After the midterm, I will look at everybody's marks up till that point. Obviously, this is only a halfway mark, and I will give you an indication. I will send each person an individual email with an indication as to how I think they're doing up to this point. Most importantly, if you're not up to date, I'm going to let you know what things you have to complete to make sure you get a good mark in this class. Okay, looking at question number 1, it says 3x squared equals 48. Now, I noticed right away that what it is a quadratic equation, because it has an x squared in it. So remember what I said, whenever you have a quadratic equation, we're talking about up till now, because after this, there are going to be other ways of doing quadratic equation, but as of now, the only way we learned how to do a quadratic equation is if we got it equal to 0. So I'm going to bring the 48 to the other side. So that I'll have 3x squared minus 48 equals 0. And I know once I have the equation equal to 0, then I'm going to try and factor as much as I can. And of course, the first type of factoring that I always look for is what's called a common factor. And there is a common factor of 3. So I'm going to pull out the 3, and I'm going to be left with x squared minus 16 equals 0. Now let's go over here, need some more space. I see this x squared minus 16 itself can be factored further. So we factor this into x plus 4 and x minus 4. Remember, when you have 2 terms, the first one has to be a perfect square, which it is. It's x times x. The second one has to be a perfect square, which it is. It's 16 is 4 times 4. And there has to be a minus in between them so that you can do in one parentheses the plus and one a minus. This is called the difference of squares. Okay, so now we're completely factored. After we've, remember, we don't stop when we're finished with the factoring. After we have finished factoring, we're going to take each of the factors and set them equal to 0. Now, actually, there happen to be 3 factors. There's a 3, there's the x plus 4, and the x minus 4. Now, the 3 is a factor, but I can't set it equal to 0 because 3 is equal to 3. It doesn't equal to 0. The only factors I can set equal to 0 are the x plus 4. I'm going to put that equal to 0, and the x minus 4 equal to 0. And solving each of these equations, I get x equals -4 for the first solution. And here I'm going to add 4 to both. So this is going to give me +4. So my 2 answers are -4 and 4. And I did it again, it's a quadratic equation. I got it equal to 0 and factored. Okay, so that's the case where, notice, we sort of call this an incomplete quadratic equation because it only, usually quadratic equations have 3 terms, an x squared, an x, and a number. But this is incomplete because it doesn't have an x term, but we still follow the same pattern. We factor, don't forget, this is the difference of squares. You just have to look at it and you know how to factor it. Okay, let's go to the second question. X times 2x minus 11 equals -12. We want to solve this. So the first thing we're going to do is remove the parentheses. So we'll get 2x times 2x, which is 2x squared, and x times -11, which is -11x, equals -12. And of course, again, I see what I'm dealing with here is a quadratic equation because I have an x squared. If we have an x squared, then the next thing we want to do is get it equal to 0. So I'm going to bring this -12 to the other side so that I have 2x squared minus 11x plus 12 equaling 0. And again, now we're got it, our quadratic equation. We have it's a quadratic equation because it has an x squared. We know it's equal to 0 now because we made sure everything was on one side. So our next step is to factor. And in order to factor, the first thing I look for is a common factor. But this 2 doesn't go into the 11, so there is no common factor. And since we have a leading coefficient, the number in front of our x squared, we have to do what we call the AC method. We have to multiply the first term, the a, by the last term, the 12. So my AC is going to, I really should probably not leave this open here. So, but my AC we see is 2 times 12. It's a positive 24, which means that we're looking for we want to get 2 numbers that are going to multiply to 24. But when we add them, because this is positive, our answer is going to be 11. Well, obviously a -11. Obviously, what that means is both numbers are going to have to be negative. So that we'll have a negative times a negative to give us a positive. And the numbers that multiply to 24 are either 1 times 24, 2 times 12, 3 times 8, 4 times 6. I think that's about it. And the ones that are gonna add up or combine to 11 are the 3 and the 8. In other words, let me put this one over here. Just rewriting it so I'll have room over here. So I'm going to take this negative 11x and break it up into a negative 3x and a negative 8x. My point in the AC method is to get a number that multiplies over here and combines to the middle so that I can break up the middle into two numbers. So now I have 2x squared minus 3x minus 8x plus 12 equaling to 0. We've just taken this negative 11x and broken it up into the negative 3x and the negative 8x. So we can do what we call it the grouping method. In my first group, my common factor is just plain x. And I have an x times 2x minus 3. In my second group, I have an 8 and a 12, so the common factor is 4. But since I'm starting with a negative, my common factor has to be negative 4. Whatever sign is in front of that first term of the group, that you take as part of your common factor. Now, when I divide the negative 4x into negative 8x, I get positive 2x. And when I divide the negative 4 into the positive 12, I get negative 3. So that we see that my common binomial factor is the 2x minus 3. And we're going to multiply it by both things that we have on the outside, which is the x and the minus 4. And this is equal. Now, we don't stop here. This is just the factoring part. We have to go a step further and set each of these equal to 0. 2x minus 3 equals 0. And x minus 4 equals to 0. So here I'm going to add 3 to both sides, which will give me 2x equals 3. And obviously, if 2x equals 3, then that'll give me, dividing both sides, let me just write this over here. I have the 2x equal to 3. So when I divide both sides by 2, my first answer becomes 3 over 2. The other one we get by doing, we have x minus 4 equals 0, so I add 4 to both sides. So it gives me x equal to 4. So the solution, and this is look at how many steps this entails. You really have to be careful. You have to first remove your parentheses, do your factoring. Make sure you know how to do that factoring. It's so important for you to be able to factor properly so you can solve the equation. And your solution to this quadratic equation then became 3/2 and 4. You have these two answers. Don't forget, when you have quadratic equations and also when you have absolute value equations, remember we reviewed those the other day on Monday, you're going to have two solutions. Okay, this was the, this was the third question that I had given you, which says that we have 4x squared plus 12x equals 0. And again, this is a quadratic equation because we have an x square in it. So, and we already have it equal to 0, so I don't have to bring anything, I don't have to move anything. But I now want a factor. And what I look for again first is a common factor. And I have a 4 and a 12 that goes into both. So that's a common factor. And this is x squared and x. In this case, we have a common factor of x as well, because each of the terms has an x in it. Okay. Factoring out the 4x into 4x squared gives me x. 4x into 12x. So the 4 into the 12 gives me 3, and the x's cancel out. And I have now completely factored this example. So I set each factor separately equal to 0. Don't forget, one of your factors happens to be not in a parentheses because it's a single term, but it is 4x. 4x equal to 0, and the other one is going to be x plus 3 equal to 0. Over here, I'm going to divide both sides by 4. But 0 divided by anything is always going to give you 0. So your answer to this one is 0. Over here, I'm going to bring the 3 to the other side. And that's going to give me x equals -3. So my two answers for this equation is 0 and -3. This was a lot easier because the factoring was so much simpler. But again, if you notice, in each case, what we did is we got our equation equaling to 0, and then we factored and set each factor separately equal to 0 so we could solve the equation. Okay, so that takes care of our solution of quadratic equations. I think this is a very good review of the type of questions you might see on the midterm and, of course, going into the final on quadratic equations. I'm going to now spend some time doing some new work. And after then I'm going to leave some time at the end to do continued review for the midterm. Okay, so what we're going to be doing for the next, I'd say, let's do 35 minutes. For the next 35 minutes, what we're going to be doing is doing new material from chapter 5. This is not going to be included on the midterm, but it's certainly going forward. We're going to need to know it for the final. And what we were doing in chapter 5 is what we called rational expressions. And as we mentioned on Monday, the word rational has its root word is ratio, and a ratio is a fraction. So basically, we're doing a chapter on what we call algebraic fractions, fractions that don't have just numbers, but they have numbers and letters. And the first thing we talked about was how to simplify or reduce a fraction. let's just review one example of the type. We did only one type, and then we'll go on from there. Suppose I were to give you um 15 x fourth y squared over 25 x 6 y. And I said, I want you to reduce this fraction. What we said is, since both the numerator and the denominator are single terms, they're each monomials, everything here is connected by multiplication. This is 15 times x fourth times y squared. There are no pluses or minuses between the letters or the numbers. It doesn't matter if there'd be one in front. Then what we can do is reduce it by going to each individual piece, the coefficients, the x's and the y's, and deal with them each on its own individual basis. So first I look at the 15 and the 25. Remember, when we're trying to reduce, what we're trying to do is divide both the top and the bottom, the numerator and the denominator, by the same number. Now, the greatest common factor between 15 and 25, the number that goes into both of them, is 5. If I divide the 15 by 5, I'll get 3. And if I divide the 25 by 5, I'll get 5. That takes care of our coefficients, the numbers in front. Then we go on to the letters. We have x fourth and x 6. We're looking for something that'll go into both x fourth and x 6. Now the letters are the easy part in this case, because the common factor is always the one with the lower exponent. In other words, between x fourth and x 6, the common factor, the one that will divide evenly into both of them, is the x fourth. So what we do is we cancel out, or divide the x fourth by the x fourth, which means it just totally cancels out. And the x 6 divided by the x fourth, when we're dividing, what we do to the exponents is we subtract. So we're going to subtract 6 minus 4, it's going to give us 2. So this is going to be x squared. Notice the x squared is in the denominator, because that's where the larger exponent was. Where the smaller exponent is, it gets canceled out, it's gone. It's really, I did x fourth divided by x fourth and got a 1. But 3 times 1, it doesn't need, I don't have to put in that 1. The only time I have to put in the 1 is if everything disappears. If everything's gone either from the numerator or from the denominator, doesn't mean there's nothing there. It means that you're left with 1. We are reducing by dividing, so we're never left with nothing. Then we go to the y's. This is a y squared, and this is understood to be a y1. So the lower exponent is the one in the y1. That gets canceled out. The 2 minus 1 gives me 1. So I get y to the 1, or just plain y. Again, now the larger exponent is in the numerator. So the y gets left in the numerator. And then I really have to be careful to do this neatly, because otherwise there's so much crossed out, you won't know what's left. But I see in my numerator I have a 3 and a y, so that's my numerator, 3y. And in my denominator I have a 5 and an x squared. So my final answer becomes 3y over 5x squared. This is what's called reducing or simplifying the fraction. What would happen if instead of having single terms, monomials, we would have polynomials in my fraction. What if I have something that looks like this? X squared minus 8x plus 15 over x squared minus 3x minus 10. This is with monomials. This is with polynomials. This is a fraction. This is also a rational expression. But in this case, I have more than one term in either my numerator or my denominator. This actually, in both the numerator and denominator, are trinomials. This has 3 terms. This has 3 terms. You can tell because between the letters or the numbers, you have either pluses or minuses. See here, there were no plus or minuses in between. So those were monomials. So the way we deal with polynomials is a little bit different. The first thing you're going to have to do, you can't just start crossing out the x squareds and the x's and everything. You must first factor. Now that's one of the reasons this chapter is right after the chapter that we just did, because we just learned how to factor. We look at our numerators. I separately do the numerator and the denominator. I look at the top, the x squared minus 8x plus 15. Now this is the easier type of trinomial factoring because my leading coefficient is 1. I can right away break it up into its 2 binomials. The x squared we're going to break up into x and x. And then remember, we look at our last term and decide, first of all, the last term is positive, means both the signs inside both of these parentheses are going to have to be the same. Since the middle one is negative, that always tells you what they're both going to be. They're both going to be negatives. And we're looking for 2 numbers that multiply to 15. And since it's a plus, so they have to add to the 8, which is obviously 3 and 5. Again, you could check this by doing FOIL. The x squared minus 8x was 15. Factors to x minus 3 and x minus 5. We then look at the denominator. Again, it's a trinomial, and again, it's starting with just a leading coefficient of 1. So again, I'm going to break it up into my 2 parentheses. The x squared is going to be, again, x and x. And then I go again to the last term. The last term in this case is negative. When your last term is a negative, it means you're looking for 2 numbers that are going to give you a negative product. The 2 numbers that are going to multiply and give you negative means one of them has to be positive and one of them has to be negative. And now you're looking for 2 numbers that are going to multiply to 10, but now since this is minus, they're going to subtract to the 3. Well, obviously that has to be 5 and 2, because 5 times 2 will give you 10, and 5 minus 2 will give you 3. And here we have to be careful. We can't just arbitrarily put the 2 one place and the 5 the other place. I have to put the larger number where the negative is, because the middle term is negative. My larger number is going to go with a negative, so the 5 is going to go with a negative, which means the 2 is going to go with a positive. Again, if you had done FOIL, you would have seen that this is exactly x times x will give you x squared. outer is negative 5x, inner is positive 2x, which gives you negative 3x, and last is 2 times negative 5, which is negative 10. Okay, so now we totally factored out the numerator and the denominator. We can now reduce. We do that by looking for any common factor in the numerator and the denominator. And when I talk about the factor, I mean the whole unit, not just each individual letter, but here the factors in the numerator are x minus 3 for one factor and x minus 5 for the other. And the denominator, the factors are x plus 2 and x minus 5. The common factor that they both have, and happen to be a common binomial factor, is the x minus 5. We cross that out. Again, if you cross everything out, either on the top or on the bottom, you have to put them 1. Otherwise, you don't have to put on the 1. There's still things left over here. I can't cancel out anything else because I can't do this x with this x because this x is part of a unit. The factor is the whole x minus 3. So my final answer comes out to be x minus 3 over x plus 2. In other words, once you've done your factoring, the reducing becomes just a matter of canceling out the like factors, the like parentheses. Okay, I'm going to give you another example for you to try that's going to be similar to this one. X squared minus 14x plus 45 over x squared minus 81. See if you could reduce this polynomial. I'll give you a couple of minutes to try it. While you're doing that, I'm going to be taking attendance. Olivia, Isis,
Yeah.
Isis, you're here? Okay, good. Alvaro. Lewis Hart.
Here.
Hi,
Good morning.
good morning. Emma.
I'm here.
Hi, good morning.
Morning.
Demetrius. Desmond. Shania. Caden. Kayla.
I'm here.
Hi, good morning.
Morning.
Sanjita. Oriana, Tahira.
I'm here.
Hi, good morning. Michaela. Kiana. Carly. Hi, good morning. Jenna. Tatiana.
Here.
Hi, good morning.
Good morning.
Naya, I know you're here. Kazandu,
Good morning, Professor. I'm here.
good morning. Trina. Trina Small. Jean. Hmm. Hi, hi Jenna. Okay, see you're here.
Good morning.
Morning. I'm just checking the participants list, so should see if it works out now. Okay, got it. Yeah, I saw you were here, Kiana. Okay, let's see if we can do this problem now. All right, again, I see that this is a fraction that consists of polynomials. The top happens to have three terms. It's a trinomial, the bottom is a binomial. We know when we have that, we've got to factor. So let's first break it up into our factors. So the top is one of those trinomials that starts with an x squared. So I write my two parentheses, x and x. And the last term is plus. That means both, I'm looking for two numbers that are giving me a positive answer. Either they're both pluses or they're both minuses, but since the middle term is negative, we know they're both going to have to be minus, because minus times minus will give us a positive answer. And we're looking for two numbers that multiply to 45. And when we add them, they're going to give me 14. I think everybody might notice that it's going to be 9 and 5, because 9 times 5 is 45, and 9 plus 5 is 14. And of course, they're both going to be minuses, so that we get the negative 14. Okay, now let's go to the bottom. The bottom happens to be just 2 terms, but it's our special 2 terms of a perfect square minus a perfect square, the difference of squares. So again, I'm going to break that up into 2 parentheses. X squared will give me x and x. And the 81 is going to give me a 9 and a 9. And of course, one has to be plus and one has to be minus. And now that I have everything factored, I'm going to cancel out the like factors. That means the whole parentheses. Now here's an x minus 9. Can I cancel out with an x plus 9? No. In order to cancel out, it has to be identical. The only thing that might be different is if it was a different order. We'll talk about that another time. But here we have an x minus 9 and an x minus 9. Those can cancel out, and I'm left with x minus 5 in the numerator and x plus 9 in the denominator. And this would be my answer. I hope some of you had gotten that answer as well. I want to spend another 10 minutes, and I want to talk about, this was reducing fractions. I want to talk about multiplying and dividing of fractions. Now, work over here. Can I erase this yet? Anybody have any problem with my erasing it? Okay. So let's talk about, before we do anything with rational expressions, with variables, let's just talk about the rules that we're involved in when we want to multiply and divide fractions. Suppose I had this 8/7 times 14/. (14/42). We want, suppose we have these 2 fractions that we want to multiply. The basic rule in multiplying fractions is just to multiply the numerators together and then to multiply the denominators together. Separately the numerators, separately the denominator. Except what happens when you do that is you're left with very large numbers, and then you have to reduce or simplify your fractions. So what we try to do when we're doing multiplication, and we'll see it works with division as well, is we try to do something that's called cross canceling or cross reducing. And what that means is, to start reducing before you even do the multiplication, do the reducing first and then the multiplication. It makes for a much simpler numbers to deal with because you're dealing with smaller numbers. Now, how do you do that? You start with your first numerator, which in this case is 8, and you look if there's any denominator, either in the same fraction or in the second fraction, that you could find a common factor. Now, between the 8 and the 7, there's no common factor. But if you notice, between the 8 and the 42, we could divide both of these by 2. There's a common factor of 2. So that's what I'm going to do. I'm going to divide the 8 by 2 and get 4. And I'm going to divide the 42 by 2, and it's going to give me 21. I have what we said cross canceled. We reduce a numerator with a denominator. It always has to be a numerator with a denominator. It can't be two numerators. It can't be two denominators. It has to be a numerator with a denominator. Okay, I then go on to the next number that I see, which is the 14. I'm looking on the top, and I ask myself, is there anything I can cancel out in the denominator with the 14? Well, if you notice, I see the 14 and the 7 could both be canceled out of 7. So if I cancel out the 7 from the 14, if I divide this 14 by 7, I'm going to get 2. And if I divide the 7 by 7, I'm going to get 1. Now, the only time I have to actually put in the 1 is if there's nothing else in. If this would have been 1 times 5, I could have just left the 5. But when there's only a single number there and it totally cancels out, don't leave it out. It is, there's a 1 left here because we're quick dividing out the 7. Notice there's still a 21 over here. But neither the 4 can cancel into the 21 or the 2 and the 21. I have canceled out as much as I possibly can. I've reduced as much as I can. Again, any numerator with any denominator. And it doesn't have to be in the order that I did it. It just has to be as much as you possibly can. Once you finish that, then you can multiply the numerators together. 8 times 2, 4 times 2 will give you 8. And 1 times 21 will give you 21. And it gives you your answer already reduced. So that is the advantage of doing this cross reducing or cross canceling, is that you get your answer in its simplest form before you actually do any multiplication or before you do any multiplying or dividing. In terms of this was the multiplying, when you're dividing fractions, okay, let's do an example, and let's do one actually that has some letters in it as well. If you have a division example, let's say I gave you 11 a squared b over 5ab squared. I'm adding in a few letters, but I'm just doing monomials, so it's going to be similar to just numbers. 22a3b squared over 10ab fourth. Okay, this actually happens to be a division example involving rational expressions, because not only do we have numbers, we have letters as well. Okay, what do we have to do? The only difference between a multiplication fractions and a division of fractions is one step. When you have one fraction divided by another fraction, what you're going to do is you're going to change the division to a multiplication by taking the reciprocal of the second fraction. You're going to leave your first fraction alone, so the 11a squared b over the 5ab squared is going to stay the way it was. But the second fraction, we now change the division sign to a multiplication, and we take the reciprocal. We put the numerator on top, the denominator on top, and the numerator on the bottom. That's the only thing they have to do. So step one, we look at your question. If it's multiplication, you could go straight ahead with it. If it's a division, if you have a division sign, first rewrite your problem by taking the reciprocal, flipping over the second fraction. And then we're going to do what we did before with the multiplication. We're going to try and cross cancel. And I'm going to do it by I'm going to first look at the numbers, then I'll go back and do the letters. The first number I see is an 11. Is there anything I can cancel out the 11 with in either the first fraction or the second fraction? It has to be in the bottom. The 11 is on top. We have to look for something on the bottom, and I see this 22. I'm going to cancel out the 11. Notice I'm not even putting the 1 there because I still have things left. I only put a 1 where everything has disappeared. And this 11 into 22 will give me 2 over here. Now, I'm going to have to be very neat. Okay, I'm now going to go to the 10. As I said, I'm first dealing with the numbers, and I'm going to go back and deal with the letters. The 10 here, is there anything I can cancel out the 10 with? Yes, I see a 10 and a 5. So 5 divided by 5 will cancel out, and 5 into 10 will give me 2. I'm not finished though with the numbers yet, because I have a 2 on top and a 2 on bottom. I can cancel out these 2's as well. Notice everything except the letters has been canceled out. So now let's start looking at the letters. Remember, when we're canceling or reducing the variables, we cancel out the lower one and subtract the exponent from the higher one. So the first thing I'm gonna, these are all piece by piece. I have an a squared here. I can cancel it out with the a cubed over here. The a squared is the lower exponent, so it gets canceled out. The 3 minus 2 is 1, so this gives me just a plain a. I'm just going to go straight across the top until I don't see anything that I can cancel out anything anymore. Now I have a b. Is there anything I can cancel out the b with? Well, yes, there's a b squared in the same fraction. There's a b squared in the opposite. But it doesn't matter. Any numerator with any denominator. So I'm going to cancel out this b. Notice everything's been gone from this numerator. I better put a 1 there. When everything is gone, I put a 1 there. And this exponent was 1. 2 minus 1 is 1. So this becomes b to the 1, or just plain b. Let's keep going. The next thing I see, I'm up to here, is my a. Is there anything I can cancel out the a with? Well, right in the same fraction, there's an a on top and an a on the bottom. So I can cancel out this a with this a. Remember, they totally cancel out. I can just can't cross them out. And the last thing I see on top is b4. Is there anything I can cancel out the b4 with? Well, yes, here's a b4 and a b squared. So the lower one is the b squared. Notice now this is all gone, so I'm just left with a 1 here. Notice when everything is canceled out, I put a 1. The 4 minus 2 is 2, so on top here I have a b squared. And just looking, I still have a b on the bottom and a b squared on the top. So I can cancel out this b, that's the lower one. There's still something here, so I don't have to put that 1 here. And 2 minus 1 is 1, so this is b to the 1, or just b. And if I look what I'm left with, I have a 1 times a b, because everything else has been canceled out, which is just a b in the numerator, over a times 1, which is just a. My final answer after all that is b over a. If you notice, what you're going to have to be very careful about is being neat, especially to make sure that something was either crossed out or not crossed out. Let's just do one more example. And then we'll go back to a review for the midterm. Okay, I'm going to do another example, but now I'm going to do an example that involves polynomials, not just monomials. What if I gave you this example, x squared minus 9 over x squared minus 10x plus 24 divide by x plus 3 over 2x minus 12. We want to divide these two rational expressions. And in this case, we're dealing with polynomials. So the first thing we're going to do is what we did before. Whenever we have a division example, we're going to rewrite the example. We're going to do x squared minus 9 over x squared minus 10x plus 24. We leave that first fraction alone. Change the division to a multiplication by putting the denominator, the 2x minus 12, on top, and the numerator, the x plus 3, in the bottom. We change our division example to a multiplication. And just like when we had reducing of fractions, when we are multiplying or dividing fractions, if they're polynomials, the first thing you've got to do is factor. So after you change your example to a multiplication, your first step is factor in both simplification and multiplying and dividing. Again, once you have your setup so that it's a multiplication example, you're going to first factor so that you can cancel out like factors. Well, the x squared minus 9 is our difference of squared. So that's going to break up into our two parentheses, x plus 3 and x minus 3. Whenever we have two terms, that's what we look for, is with the difference of squares. We then go to the x squared minus 10x plus 24. Again, that's a trinomial that starts with a plain x squared, so I can put it into two parentheses, x and x. And since the last term is positive, it means both signs in the parentheses are going to be the same. They're both gonna have to be minuses to make sure that we're gonna get a negative 10. The negative times a negative will give us a positive 24, and when you add them, it's gonna give us the negative 10. So we're thinking, what numbers multiply to 24, but add to 10? And I hope everybody realizes it's gonna be 6 and 4. And it doesn't matter where I put the 6 and 4 because they're both gonna be minuses. Negative 6x and negative 4x will give us a negative 10x. Okay, let's go to the next fraction. Remember, all I'm doing now is factoring. 2x minus 12 has a common factor of 2. 2 goes into both of them. So we got 2 times x minus 6. And the x plus 3, there's nothing we can do with it, so we just bring it down. So now we've completely factored. So now we're going to cross cancel. We're going to look for any numerator that can cancel out with any denominator, and I'm going to go straight across my numerator. The first thing I see is an x plus 3. Is there something I can cancel out the x plus 3 with? Remember, binomials have to be just totally canceled out, the whole thing. You can't do piece by piece. On polynomials, on binomials, it has to be the whole expression. Well, there's an x plus 3 here and an x plus 3 here. Now, this is totally gone from this denominator, so I'm going to put a 1 there. I put a 1 where everything is gone. Otherwise, if there's something still there, I'm not too concerned. Now there's an x minus 3. Is there anything I can cancel out the x minus 3 with? The only thing it would be another x minus 3. There is no other x minus 3. So I go to the next thing. Next thing I see is a plane 2. The only thing a plane 2 can cancel out with is a plane 2 on the outside. It can't be a part of a term of a binomial. It has to be its own special. Its factor here is the 2. There is no 2 that just stands alone. So I go to the next factor, which is x minus 6, and there's an x minus 6 here with an x minus 6 here. And now I canceled out everything that I possibly can. What am I left with in the numerator? I have an x minus 3, and I have a 2. Now, usually when you have a single number, you put it in front, but if you would put it after the x minus 3, it would be perfectly okay. And at the bottom, all I'm left with is an x minus 4. And you can leave your answer like this, or if you prefer, and if it's a multiple choice, I would suppose it would be left like this, but you could also use a distributive property and write this as 2x minus 6 over x minus 4. Don't think you can reduce these or these. When it comes to binomials, it's a whole unit. It has to be identical. Okay, so this is where we're going to be continuing on Friday in terms of new material. We talked about reducing fractions and multiplying and dividing. On Friday, we'll talk about how do we add fractions and subtract fractions. But now let's go back and do some review for the midterm. And number one, I wanted to, the one thing that we hadn't done from chapter 1 in terms of the midterm is what we call those perimeter problems. I want to review how we do a perimeter problem, and then I want to go into talking about writing equations of lines, which is probably the most difficult part of the midterm. Again, by Friday, you should have at least done one the midterm preview at least once. I will give you over the weekend to do more than it's, I think I gave you time to do it more than over the weekend as well. But don't leave it for the last minute. Do it at least once before Friday, so that if you have any specific questions on types of problems, you can ask me. You can ask me how to do those different types of problems. Okay. So first, let's talk about a perimeter problem. Let's say I gave you an example like this. A swimming pool has a perimeter of 100 meters. And the length is 12 more than the width. And we're asked to find the dimensions. In order to make this go quicker, I'm just going to do these problems with you. Okay, if you remember what a rectangular pool would be, a rectangular pool, it would be a rectangle that has the two pairs of opposite sides equal. We're told that the whole perimeter, that means all around, is 100 meters. And that the length is 12 more than the width. So if I call the width X, my length has to be 12 more, it will be X plus 12. If it says the length is 12 less than the width, then instead of doing plus 12, you would do minus 12. Remember, the more or the less number is always put at the end. 12 more means plus 12, 12 less means minus 12. If it says the length is 12 less than twice the width, then you would have to do 2x minus 12 in order to get the length. Now, this will also be equal to x because the opposite sides are equal, and this will be x plus 12. If you remember, the perimeter is when you add all the four sides together, and I'm going to add them all up. X, 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 there are 4 x's, and 12 is 24. And this whole thing has to add up to the total perimeter, which is 100. Here is our equation. I'm going to bring the 24 to the other side. So that'll give me 4x equals 76. And when I divide by 4, and here's where my calculator comes in handy. I do 76 divided by 4 is 4 and 2 is 19. Which means that the width is equal to 19 And the length is 19 plus 12, which is 31. And that's my dimensions, 31 by 19. Usually they put a little X in between them, or you could say the length is 31, the width is 19. So that's how you do these perimeter problems. Don't forget, you have to add up all four sides when you're talking about the perimeter of a rectangle. Okay, so that basically takes care of chapter 1. Going on to chapter 2. Chapter 2 is the whole concept of writing equations of a line, the y equals mx plus b business. So let's just do a few of those type of questions. Number 1, I want you to write the equation of a line which passes through the points -2, -1, and -3, -4. So here I'm giving you 2 points on the line. I'm asking you to write the equation of a line. Again, remember that when we're talking about a line, we're talking something written in the y equals mx plus b form. Sometimes it's not given in that form, sometimes we have to put it into that form, but basically that's what we're talking about writing the equation of the line, where the m stands for the slope of the line and the b is the y-intercept. So if we want to write the equation of this line, the first thing we want to do is find the slope. And the slope we're going to do by doing the slope formula y2 minus y1 over x2 minus x1. Let's call this our x1. y1, let's call this the x2, y2. I know I'm doing this quickly, but this is basically review. So it's going to be y2, which is -4, minus -1. That's my y1. Remember, the y is on top. The x2 is -3 minus the -2. Now let's be careful. When we have two negatives, it becomes a positive. So it becomes -4 plus 1 over -3 plus 2. And -4 plus 1 gives me -3 in the numerator. -3 plus 2 gives me -1 on the bottom, which reduces a negative over a negative, becomes a positive. The slope of this line is 3. Now, when I look at I might stop right now, and remember, we're doing a multiple choice test. So if you see a line, only one of the lines has the correct slope. Only one of them of the choices they're giving you is y equals 3x plus something. You probably could stop right there, because that could be there could only be one right answer. Usually that's not the case. Usually they give you a couple with the right slope. So now we have to go to the y equals mx. Well, our m we know is now 3x plus b. And in order to figure out what the b is, we're going to take one of the points. It doesn't matter which one. I'll just take the first one and replace the x with a -2 and the y with a -1 and see what happens. So this will give me -1 equals 3 times -2. This is the 3x, is -6 plus b. All I have to do is bring the 6 to the other side. So they'll give me -1 plus 6, which is 5, equal my b. So now, not only do I have the slope, which is 3, and the b, the y-intercept is 5, I can now write my equation. Y equals 3x plus 5. So that's how we write the equation of a line given the 2 points, which allows us to find the slope, and then figuring out the equation, the B. What if I have an example like this? I want the equation of a line going through the point -2, -1, and perpendicular to the line 5x minus 15y equals 12. And sometimes we talked about lines that are parallel, and sometimes we talk about lines that are perpendicular. When the lines are parallel, they have the same slope. When the lines are perpendicular, the lines are what we call negative, or let's call it, not call it negative, let's call it opposite reciprocal slopes. Whenever we want to write the equation of a line, the first thing we really want to do is get the slope of the line. Now, we know in our particular case, we want a line that's perpendicular to this line. So we know that the line we want to write has to have a negative reciprocal or an opposite reciprocal slope. But I don't know what the slope of this line is. I have to first put this line, the original line, in the y equals mx plus b form by getting the y alone. So I'm going to minus the 5x from both sides. That'll give me negative 15y equals negative 5x plus 12. And then divide everything by the negative 15 to get the y alone. Okay, so what are we getting here? We're getting y equals, well, we're going to reduce this. Negative 5 over negative 15, that can be reduced to 1/3. So it's 1/3 x plus 12 over negative 15. I'm not even bothering with this part because what I'm looking for is the slope here. The slope of my original line is 1/3. So the perpendicular line, if the lines were parallel, the slope that I would be looking for is 1/3 because parallel lines have the same slope. But I'm not, I'm looking for perpendicular lines. The perpendicular line is going to have a slope of, flip this over, 3/1 and change its sign. It has to be an opposite reciprocal sign. In other words, it has to be -3. If the original slope on the original line was 1/3, on my perpendicular line, it's going to be -3. So now I can write my equation y equals negative 3x plus b. Again, I figured out what the slope is. I didn't figure out what the b is. So we do what we did before. We take the point. Remember, first we figure out the slope, then we go back to the point that they give us. In this case, they only gave us one, so that's the one I have to use. In place of the x, I'm going to put a -2. In place of the y, I'm going to put -1. And see what happens. I'm going to get -1 equals -3 times -2, which is +6 plus b. If I bring the 6 to the other side, it gives me -1 minus 6 is -7 is my b. And therefore, I can now write my equation. I have my slope. I have my y-intercept. So my equation is y equals -3x minus 7. So there's a lot of steps involved here. First, you have to take the original equation they gave you, put it in the y equals mx plus b form so you could find its slope. Then you look, does it say perpendicular or parallel? If it says perpendicular, flip this number over, switch its sign. If it says parallel, just keep that number and take your point and stick it in to the equation to get the b. I saw that you were here, Sanjia. Oh, this is Shania. Okay, I'll change that right now. Okay, there are two special lines that we have to remember how to write the equations of. One is what we call horizontal lines. And we also have vertical lines. And these, you just have to remember, these are very easy to remember because each one of them doesn't have an X and a Y. They just either have an X or a Y. A horizontal line is Y equals a number. A vertical line is X equal a number. Here, the slope of the horizontal line is 0. And the vertical line, the slope does not exist. It doesn't have a slope. But if you say, let's say, write the equation of a horizontal line through the point -5, -7, let's say, the horizontal line would be y equals -7, because with the horizontal line, you just have a y value, y equals. If it asks for a vertical line through this point, it would be x equals -5. notice the X is always the first number, the Y is the second number. So when you're writing the horizontal line, you're writing Y equals a number, you're writing the Y equals to the -7. And the vertical is X equals -5. So those are your two special lines, vertical and horizontal lines. Another thing that we had done in the chapter 2 is what we called functional notation. If I gave you something like this, f of x is equal to 3x squared minus 2x minus 10. And I said find f of -2. Then what that's telling you to do is to, in place of the x, put in -2 and the other side, on your other side of the equation. You're replacing the x over here with -2. That means over here as well, you must replace it with -2. So you're going to get 3. In the place of the x squared, we're going to do -2 squared. And don't forget to put it in parentheses to include the whole number. -2, here's in my x, and putting in my -2 minus 10. You could either, if you want to put this into your calculator, you can, but you have to put in those parentheses as well. If not, don't forget when you're doing first exponents and then multiplication. So this would be -2 squared, which will give you 4. And you'd have to then multiply the 3 times 4. So this will give you 12. Then we'll have -2 times -2, which is +4 minus 10. And 12 plus 4 is 16 minus 10. So your final answer in this case would be 6. So don't forget to be careful with your order of operations. Okay, I think right now we're going to stop. Basically, I'm going to review chapter 3 and a little bit of chapter 4. We did most of a review of chapter 4 already. We've reviewed the factoring and the quadratic equations. I just want to do some adding and subtraction of the polynomials. So that's what we'll start with on Friday. We'll finish our review, and then you'll be ready to take your midterm. Don't forget, if you have any specific questions, you can ask them to me on Friday. Does anybody have any questions right now? Okay. Then I'm going to say, have a good day. Don't forget to do that practice midterm. It's already available and you should be doing it already. I did see that 1 or 2 people had done it. Make sure you do it. With no questions, I'm going to end this session now.